Hello, it's Keith here, and this is lesson 4 of the simple series of my Z80 tutorials. In this series we create really simple basic examples just with a single assembly file, so no including of other files, no multi-platform support, but this is the stuff that will get you started as easily as I can manage, and also it'll allow you to take that code and then build up something your own. So what we're going to do today is we're going to show a simple sprite onto the screen, a bitmap sprite using software sprites because the Sam Coupe has no hardware sprites. We're going to learn how to do that because we're going to learn how to set up the screen, and hopefully that will give you something to get working with. Well, before we look at the code, let's just run the example we're going to look at today. Okay, so here's our basic first example. So we've got an 8x8 tile here, a little smiley face. Now this is a 16 color mode on the Sam Coupe, very nice color mode. So the Sam Coupe is a really good option if you're looking for color graphics at high resolution. It's 256 by 192, so this is competing with the MSX2 for graphic capability. But personally, I find the way the Sam Coupe works is a bit more simple because you don't have to work with ports and complex graphics hardware. So anyway, that's what we're going to be working with. Well, let's have a look at our code. So this is the entire file. Now, if you don't know how to compile an assembly file and execute it on an emulator, please have a look at my previous simple example, the Hello World example for the Sam Coupe, because we went over all of that there, so we're not going to go over it again today. So what we're going to do today is we're going to start our code at hexadecimal 8000. Now, the Sam Coupe screen is a massive 24 kilobytes in size, and our system can only address 64 kilobytes. And because of the way the paging works, we're going to have to page out half of our memory to load the screen in so we can change it. So we're going to load it into the low part from 0 to 7FFF. So our code's going to start from 8000 because otherwise the bottom part of our code would vanish when we did that. So that's going to be a little bit tricky. And that also explains why we're disabling interrupts here. Now, interrupt mode 1, the default, will actually use memory address hexadecimal 38 as the interrupt handler. So whenever an interrupt occurred, it would call that address. Now we're going to page our video memory into that location, and so it would effectively run whatever bytes our screen ended up producing, which would be crazy, it'd go crazy, so we won't want to do that. The easiest thing is just to turn the interrupts off, but if you're playing with music and things, that's going to be a bit difficult. Now I know this is more than you should be looking at early stages, but if you need a way around that, then the option I'd suggest is use interrupt mode 2, and I have a tutorial on that. But as I say, for a basic example, if you're just starting out, just turn interrupts off. You don't need any music to get something really going, and at the point where you start to think of that, I think you're going to start to understand your options a bit better then. Okay, so we're turning off our interrupts, and then we need to make sure we've got a good stack pointer. Again, can't be below 8000, or at least if we're using calls. So we've got a call here, so we got to have a good stack pointer. So we're loading it at BFFF here. That's a good place. So that's what we'll be working with. And now what we need to do is we need to turn on the low bank, and we need to set it as the visible video screen. Now that's what we're doing here. So this first option here is selecting the video memory page. This is selecting a memory address to use as the screen. Now the memory address numbers are numbered based on 16 kilobyte blocks, but the paging is actually done in a 32 kilobyte blocks. So what we're doing here is we're selecting page 14, and by convention 15, because we always specify the next one as well because it's 32 kilobytes. So we're selecting 14 and 15 as the screen banks that are going to be visible by the system. So whenever we page those in and write to them, it will just immediately appear on the screen. So why are we selecting 14 and 15? Well, these are the last two banks of a 256K system, which I believe is the lowest specification. There was a 512K system, but that might not be available. So by using that, we've got tons of space for our program code, but we've got these two paging banks within the reliable memory that we know will be in the system. So we're just writing that here. We're setting the screen mode here, but really you're always going to want to work with the 16 color mode. There's some Spectrum compatible modes, but I wouldn't worry about those. We just write that to port 252 with an out command. And then next what we need to do is we need to actually make that same bank available, because you can see we've got the same bits here. We're going to use that same bank, and we need to select that as the low memory bank so that the 0 to 7FFF range is that bank that the screen is showing. So we select the same bank here. You can see this selection is the same. And then we need to turn off the ROM of the Sam Coupe, which would usually be down there. So we put a 1 here, and that will turn the ROM off. Now, at this point, we're on our own. We can't use the ROM, but I always try and avoid using the ROM anyway, so we won't have a problem with that, and we're going to learn how to turn the ROM back on later anyway. So we're now ready to actually start drawing to the screen. So we've got our sprite here. This is one nibble per color because it's 16 colors. So this one here would effectively set the left hand side pixel to 1. This would set it to 3, and so on. Very straightforward format. So this is our smiley face, and you can kind of see the 1s make a circle here, and the 2s make a smile, and these 3s are the eyes. So very straightforward really. We've got 2 commands we use. Get screen position. This takes BC as an XY position, and it returns DE as a destination memory address within the active screen memory at those low ranges of the memory. Now I should say you could set the screen to the high areas, but that's not the way I do things in my tutorials. So it's up to you if you wanted to do it the other way. It's perfectly possible to change the banking of the high range. Now calculating the screen position is very straightforward. All we need to do is effectively multiply the Y position C by 128 and add the X position. Now the way we do a multiply is we effectively do a bit shift. We load the high byte with the Y position, and then we shift 1 bit to the left, moving it into the low byte. Now effectively the top bit of the low byte is worth 128, if that makes sense, and that is effectively multiplying the Y position by 128. Then we just add the X position. Our screen starts at 0 memory address anyway, so we've got no offset for that, and that will do it. Now if you don't understand it, just use it as is. It will work just fine, but that's the logic that I'm using here to calculate the screen address. So that's what we're going to do there. Now the next thing is we're going to do the get next line command. So once we've got to the end of one of the lines of our bitmap, we need to move down to the next line. So I'd use a simple command. It just adds 128. Each line's 256 pixels wide, 2 pixels per byte. So we just add 128. That will move us directly below the current line. And so we add that to E, and then if E is overflown, going over 255, we need to increment D to compensate. So that's going to move us down the line, and that's what we use in this code here. So we calculate our screen position based on BC, so that's the location we're drawing to here. We then set IXL as our line count just here, so we're setting that to 8. IXL is a kind of rare register, but it works just fine. And then we're loading HL with our sprite address, and that's the sprite, that's the smiley face down here. Now each line of this sprite is 4 bytes wide, so we load BC with that, and then we use ElDir. This is a fast Z80 command. It takes in a byte from HL, writes it to DE, increments HL and DE, and decreases BC until BC reaches 0. So that's why we're having to use both B and C here. I'd have preferred to use just B, but then we couldn't use ElDir. So that's what we're doing there. We're backing up DE before we start and restoring it when we end, and that means that DE will be pointing still to the left hand side of our sprite when we use our get next line command. So that's why we're doing that. Then we decrease our Y line counter and we just loop back here, and that's why we're using IXL, because it's one of the few registers that's spare after that ElDir command has used HL, BC and DE. So that's why. We're effectively done with our sprite, and then the last thing we're doing is we're turning off the ROM. That's because this bit is now 0. I think it's this one here. You can see here it was 1 before, last time we used this command. And we're changing the bank number here. We're effectively selecting the last possible bank, and that will effectively mean that the low area 0 to 3FFF will be ROM, and then the next area will be bank 0 of RAM. So that's why it's doing that. It's selecting the highest possible bank, even if it doesn't exist on that 256K system, so that the first bank after the ROM is 0. So we don't need to do this in this example though, because I'm actually halting the processor here, just locking up the machine. So it doesn't really matter what the ROM's doing or what the banking's like. But if you were going to use your own code and you were wanting to use the ROM for things, then I thought best give you the easiest way to get things back to normal so that I don't cause you more trouble. So that's what we've done there, turned everything back on. So that's how we draw our silly little smiley face. You know, a nice little example. You could use it as a simple tile routine, or if you're using really tiny sprites. But it's really easy to get things a little bit better. So in this case, we're including a file here, and you'll notice it's called raw MSX. That's because it's the same format as the MSX. And we're going to use this Chibico sprite here. This is my character Chibico. And this is my Aku Sprite editor. It was written originally for Chibi Akuma's the multi-platform version, but it's now part of my tutorials, and you can see this huge list of systems here. Every system I cover, I put in some basic functionality to save the sprites to. So if we go to our Z80 option here, Sam Coupe, File, we've got Save Raw Bitmap here, and that will save the file that you see here in the format that we need today. And as I say, it's actually identical to the MSX. So this code's almost identical to the last one. Let's just run it. And she's in the kind of wrong colors here, but we've got our Chibico character. And you can see it looks okay. So you got the pink and the red here, so it is two different colors. They just look very similar. And you've got the blue here. Now this is obviously only 4 colors, but that's just because of the sprite that I exported. This mode is a full 16 color mode. So we got our Chibico character there, and it's drawn to the screen just fine. And because of the way I used the ElDir before, it's very easy to change. We just change IXL to the height, 48 pixels, and then we change BC to the width. It's 48 pixels, but that's 24 bytes. So we've just got to divide by 2 to calculate, and that's all we do there, and that's how we draw it. And the rest of the code is exactly the same. So there you go. We've learned how to draw some nice graphics on the Sam Coupe. Pretty easy, really. Now, if you're going to get quite advanced and you're going to use a lot of memory, you're going to have to start thinking about how you're going to deal with that bottom area of the screen, because as I say, if you're going to page in and out the bottom bank, it'll get in your way. And if 24K of that bank is being used by the screen, maybe you're going to need to do a lot of paging. But you're going to have options there, and it's not going to be something you're going to want to worry about in the early days. If you're making a simple race car game or a Tron game or something, then your 32K of top memory should be fine for you to get started. And as I've said before, you just want to get started. And by the time these things are becoming problems for you, I think you're going to start to have your own ideas of how to solve them, so it shouldn't be too much to worry about. Anyway, I hope you've enjoyed this today. We're going to come back to this later again on the Sam Coupe. We're going to be adding some input routines, and so hopefully, you'll have it in at least a template so you could get started writing your own little game. Thanks for watching today, and goodbye. If you enjoyed today's lesson, please check out my website. We've got tutorials, source code and development tools for 6502, 68000 and Z80 systems, and a lot more systems coming in the future. We're going to be covering the 8086 and the ARM and a few other things as well going forwards. And if you've liked this lesson, if you've got questions, comments or suggestions on how it could be made better, please consider signing up to my forum. It's free, of course, and you can come along here and you can make suggestions, you can ask questions. And if you've got assembly projects you're working on, please let us know what they are. Maybe show off a few screenshots, tell us what things you've found interesting or what tricks you've come up with, because we'd love to know about it. Anyway, thanks for watching today, and goodbye.